This is a video on curvature. The question states, find the curvature of the curve at the point P. And the curve is defined by the vector-valued function r of t is equal to ti plus t squared minus 1 j plus 1/3 t cubed k. And the point is p equals 2, 3, 8/3. So first let's recall the formula for curvature when we have a curve defined by a general vector-valued function. And that is that the curvature k is equal to the magnitude of r prime of t cross r double prime of t, all divided by the magnitude of r prime of t cubed. So let's find out what r prime of t and r double prime of t. We take the derivative of r of t, and the derivative of t is just 1, so I get I. The derivative of t squared minus 1 is 2t, so I get plus 2tj. And the derivative of 1/3 t cubed is just t squared, so I get t squared k. To find r double prime, I take another derivative. The I goes away, its derivative is 0. Derivative of 2t is 2, so I get 2j plus, and the derivative of t squared is 2t, so I get 2tk. So the point is 2, 3, 8/3. Notice that the first component t must be equal to 2 for the point to work out. And if we plug in 2, we get 2i, and then we have 2 squared is 4 minus 1 is 3, so that matches. We get 3j. And 1/3 times 2 cubed really is 8/3. So the point P is a point where t is equal to 2. So I plug in 2 in for t in r prime, and I get I plus 4j plus 4k. If I plug in 2 for t in the r double prime equation, I get 2j plus 4k. So the curvature formula says I need to take the cross product of r prime and r double prime. So I do that. I take r prime of 2 cross r double prime of 2, and I set up the matrix ijk 1, 4, 4 and 0, 2, 4. And I get I times 16 minus 8 is 8, so I get 8i. And for the j component, I have 4 minus 0 is 4, so I get minus 4j. And for the k component, I get 2 minus 0 is 2, so plus 2k. So now I have my vector, r prime of 2 cross r double prime of 2. I need to find its magnitude, and then divide by the cube of the magnitude of r prime of 2. So I do that. I take the square root of 8 squared, which is 64, and then plus negative 4 squared, which is 16, and then plus 2 squared, which is 4. And I divide by the cube of the square root of 1 squared, which is 1, plus 4 squared, which is 16, plus 4 squared, which is another 16. And I worked that out on my calculator, and I got that the curvature is approximately equal to 0.048 for this curve defined by this vector-valued function at the point 2, 3, 8/3. And I'm done with the problem.